I now intend to show how proactive reinforcement design and detailing could have converted this cage from a very difficult concreting exercise into one that could be relatively straightforward. By relocating the red bars from the outer layer to a position where they are tucked inside the blue bars, instead of the wall of steel, we now have a series of openings virtually the same as in the lower section shown by the green arrow. This is a simple example of a proactive amendment to the reinforcement detailing as drawn by the designer. This amendment could have been made by the contractor, even after the bars were all bent. However, it would have been better to do it before the bars were scheduled and bent. The most efficient way to be proactive is for the designer to detail the reinforcement in the first place so that it doesn't cause any unnecessary built-in concreting problems. The reason I put the greatest emphasis on specifying is because the specification must get it right first. That means the people who prepare the tender documents must build into them the necessary specified requirements. Carefully worded requirements can ensure that designers and drafting personnel and reinforcement suppliers and steel fixers all work together so that mistakes are prevented and quality and safety are built into our concrete structures. A well-prepared specification will also ensure that the requirements for the reinforcement are thoroughly integrated with the requirements for formwork and all concreting-related processes, including the supply of concrete. Some of you may think of a specification in terms of a typical architect's specification for a building project. This is no longer acceptable once we recognise the implications of special processes as originally defined in ISO 9001. Just as you can't fully verify the quality of a weld by visual or non-destructive testing, so you can't verify the quality of a concrete structure by product testing alone. Almost all major concreting processes are special processes. Therefore, effective quality assurance is only achieved by continuous monitoring of the concreting processes. On first thoughts, placing reinforcement does not appear to be a special process. The shapes and sizes of bars and their location within the formwork can be inspected and verified before concreting. Even the cover in the finished structure can sometimes be checked by a cover meter. For example, the top picture shows accurately fabricated cages which are rigidly tied or welded together, and where there is an adequate support system preventing displacement or deflections during concreting. However, the reinforcement in the webs of the box girder is far less rigid and can be easily damaged by careless placement and vibration of the concrete. Furthermore, if the ducts are damaged or displaced, there could be a serious loss in the pre-stress force in the structure. These new execution standards have been approved at this time to coincide with the final full implementation of common structural design standards throughout Europe by March 2010. Within a few years, these Eurocodes will replace national design standards in ex-European dominions such as India, Singapore and Vietnam, and their influence will also be felt in China. These Eurocodes are design codes, but they do make assumptions about levels of supervision and standards of workmanship on construction projects. These assumptions are really essential design requirements, and they have to be defined and enforced by appropriate mandatory requirements being stated in the project specification. The International Execution Standard is in fact a framework for drafting a project specification, and it enables the execution or construction processes to be specified one by one. For concreting processes, as for welding, both quality and safety depend on how the processes are controlled. The execution standard can be converted into a very effective specification, one which has the authority to ensure that the design requirements and necessary construction requirements are actually enforced when the work is being done on site. However, for this to occur, there must be an effective design and construction management plan. Therefore, it is imperative that the specification states clearly that the necessary management plan shall be prepared by the contractor, which includes the contractor's designer. In this slide and the next, I will give one example which ties together the concreting plan, the reinforcement plan and the inspection plan. I will try to show how some proactive reinforcement detailing could have simplified and speeded up a major construction operation. The requirement for effective construction planning is the major thrust of my published paper, and I trust you will be able to follow the discussion and put it into practice on some future contracts. This slide provides additional reasons why it can be very desirable to detail reinforcement with non-uniform spacings, so as to maximise accessibility for operators and inspectors. Most importantly, Greater openings provide access ways for concrete pumps to be inserted to the level of the bottom steel. This facilitates clean discharging from the hose and makes it possible to observe the concrete flowing under the lowest layers of reinforcement. These are extracts from a more comprehensive list reproduced in the paper. You will notice that considerable responsibility is placed upon the designer detailer. This position will need to be clearly defined in the specification, and the successful tenderer will need to demonstrate that he has people with the required qualifications to do the job. The specification must also incorporate appropriate hold points. Hold points are definable stages in the construction schedule where further construction cannot proceed until the conformity of the preceding stage has been verified. For example, in the previous case study, a hold point should have been specified for verification of all lower coupler connections before access for inspection was closed off by the upper layers of reinforcement. The last slide attempts to summarise what I see as the potential benefits of a set of international construction process specifications as I have tried to introduce them in this presentation. I hope you will find the time to study the paper and the ongoing development of these ideas on my website. Thank you for your attention.